Hello and welcome everyone. Happy Tuesday and a very happy December to all of you. Today is the seventh and the last session of this Day One and Beyond Series 3. We'll be starting our fourth series in Jan 2023. You can find the recordings of all previous sessions and the registration links for the 2023 series on the same Day One and Beyond page. I'll share the link with you in the chat window in a short while. The links for the 2023 series will not be up there right now, but you can find the recordings of the previous sessions there. So for those of you who are new to Day One and Beyond, this program takes you through a series of topics and activities related to building out on Oracle Cloud. These events are hosted on Cloud Customer Connect, which is our Oracle community forum for customers and end users. So you can create a free account to join in discussions, post questions, and look for upcoming events to various topics. My name is Renu Bhatt. I'm a TPM with the Customer Enablement Team. And today I'm joined by Rama Balaji, Director of Product Strategy, Mari Gubar from Product Management, and Larry Bosele for Senior Manager Tech Program Management. Before I hand it over to the presenters, our usual reminders that this session is being recorded and you'll have access to the recording. And please use the Q&A box down at the bottom at any point throughout the session to drop questions. With that, I will hand it over to Larry.
Awesome. Thanks, Renu. Thank you, everybody, for joining. So my name is Larry Bosele, and we're going to start another Day One and Beyond on Oracle Cloud Data Platform. Today, I'm going to be kind of learning along with all of you. So we have some experts here to talk through this with Rama and Marty going through this particular area. Rama, if you wouldn't mind going to the next slide. So our agenda today is data management is going to be our main concept that we're going to cover. And then we're going to get into some Oracle Data Platform with some demo and Q&A. If you have any questions along the way, please drop those in the Q&A and we'll look at them and try and answer them maybe as we go. But we'll definitely have some time towards the end to answer some of those questions. In this, a few notes for this, like I was saying, please put your Q&A in the Q&A of Zoom. If you do drop in chat, we'll have you pass it over to the Q&A side so that we can answer that live or while we're going through this. Thank you for joining. And here's a link you can scan with your phone, a QR code for going through the Oracle Cloud Data Platform. And once we're done with this session will be posted live by tomorrow, and they'll be on the same link where you joined or registered for this, so you can watch the replay later. Thank you for that. And I'm going to go ahead and hand this over to Rama to take us through this journey. Thanks, Rama, for joining with us today and kind of taking us through data platform and data management and what we're going to learn today.
Sure. Thank you, Larry. My pleasure here. And I am Rama Balaji. I am a Director of Data and AI Analytics Cloud Platform team at Oracle. So first, I want to talk about some of the trends that we see with customers in the market today. This is more of a discussion type session. It's not a highly prepared customer presentation slides or anything. It's more like a discussion. So first we will talk about those trends and some great examples of what we see with customers. And then we will talk about some of the challenges and then what other vendors have provided. Because I often get the question of what is the differentiator for Oracle? Why would we consider Oracle Data Platform? So this session mainly would focus on the differentiators of Oracle Cloud Data Platform versus other competition as well. And then we will talk about cover some basic concepts and how the technology evolved. And then we will introduce Oracle Cloud Data Platform and then give it over to Marty, who's going to be doing a demo of the platform. So let's
have a quick poll, Rama, before you move on to the next slide.
Oh yeah, sure, Renu. Go ahead. Thank you.
So we'll give you about a minute to do this. Less than a minute.
All right, thank you. Okay, so let's talk about some of the trends we are seeing with our customers today. Across all industries, we see great examples of how customers are converting the data into real tangible business outcomes. So what does it mean? A company called BBVA, they increased the effectiveness of their marketing campaign by 40%. And that's a good example of real tangible business outcome. A company called PaySafe, it's a payment processing company. They were mapping their customer networks to detect and reduce fraud in their real-time money transfers. That real-time is very important. Insurance company in Europe, using their GPS devices, they were able to detect the driving patterns and were able to reduce their premiums, insurance premium, or even increase the insurance premiums. And healthcare company called Prosper DTX, they were using machine learning models to predict the patient's risk factors for hospitalization, and so that they can provide recommendations on how to prevent those risks. By doing that, they were able to reduce their cost by 25%, and they were also able to ensure end-to-end HIPAA compliance. A global steel manufacturer is using video-equipped drones and AI to automate their inventory tracking. So they also created a predictive model meeting their target sustainability goals. So these are all some great examples of how customers are leveraging many of these tools to get their business outcome. Now, all companies are aspiring to do that, but not everybody is able to achieve that. There are reasons why, right? There are many challenges today. The data is coming from everywhere. They're coming from traditional legacy systems. They're coming from transactional databases. And they're also of different types. They are structured data coming from traditional databases, and they're also semi-structured data, right? There are JSON, Avro, Parquet, ORC, XML, text, all these different types of data. And then there is unstructured data, such as videos and audios, PDF files. So we need to have a place to get all this data of different types. And then there is data that is being generated by machines, like like we saw before, a company that's using GPS services. There's a company that's using video-equipped drones. So those are all data coming from machines that need to be that need to be made available for businesses, so they can do two things. One is business intelligence. Business intelligence is looking at the data that is generated today. How is my business doing? And then using the data that's generated today and the historical data, taking the data and predicting how my business is going to do in the future. That would be artificial intelligence. So these are the two requirements that businesses need out of this data. That's coming from different sources, and that's also of different types. So how are these problems being solved today? With the advent of the cloud, there are many vendors that developed their products in the cloud, in public cloud, to solve these problems. They tried to solve those problems. They've had different approaches. So there would be a vendor that would start providing data warehouse features, right? Basic data warehouse features with just structured data. And then they would start adding capabilities on top of data warehouse slowly, and start adding transaction support on top of data warehouse. So that would be one approach. There's another vendor that would start with data lake, where you can bring in all types of data, structured, semi-structured, unstructured data, and then would slowly add capabilities to give support for transactions, to support asset transactions, to support other open format systems. So basically, if you look at these approaches, they start with basic capabilities, counting on the highly scalable nature of the public cloud. They will start with basic capabilities and start adding more capabilities on top of it. So it's essentially what they're doing is they're starting with data warehouse, adding transactions and data lake on top of it. They're starting with data lake and adding database management on top of it. So combining data warehouse and data lake, and that's the new pattern that's evolving, that's called data lakehouse. And then there is the fourth pattern, that's data mesh. It's more like an organizational change to me rather than a architecture change. We won't get into the details of data mesh in this session today, but these are the three architecture patterns that are existing as of now. All right, so what's the best approach? Best approach, as we saw, everybody have one thing, everyone have realized is that unified platform, unified data platform is what provides the most benefit to customers. So why do you need unified data platform? You need it to get the data quickly and securely so that you can make decisions and take actions that affect your business. And when you make those decisions and take actions that affect your business, you are backed out by the most current data. You have the most current data. And so that you can actually predict your business outcome, accurately predict your business outcome. This is why you need a unified data platform. So what is Oracle able to provide in that unified data platform? Before jumping into Oracle's data platform, let's review some of the data concepts and how these evolved. First is transactional databases. So transactional databases are optimized for running applications for the web, banking, and retail stores. So when you go and swipe your card, your credit card, that goes into transaction applications. And if you're creating a applying for something on the web, that is going against transactional applications. So those applications are powered by transactional databases. Those transactional databases are designed for fast writes and fast reads of individual rows of data. So typically they follow this row format. Row format is a format in which all columns pertaining to a particular record is stored together in the form of row, so that it's faster to retrieve few rows of all columns, and they're all ACID compliant, right? So we won't get into the details of ACID compliant here. It's basically if you're making let's say you're transferring money from one bank to another, you're debiting from one account and crediting another account, and those two changes need to happen together. If some network failure or something happens in the middle of those two changes, both changes need to be reverted back. So that's a good example of ACID compliant. It basically ensures the data consistency.
So Rama, I'm sure there are many vendors out there. So let's find out from our attendees if they're using other vendors also for other things.
Sure, yeah. You have a poll?
Yeah, we have a poll. Again, a minute.
Ram, looking at the poll, I mean, is that kind of what you were expecting from the spread that we see here?
Yeah, I was the screen went away. Can you tell me the result of the poll?
Yeah, so we have a relatively 21% saying AWS, 8% saying GCP, 42% saying Microsoft. We got Snowflake at 17% and Databricks at 13%. Who is the vendor you most favor when it comes to building cloud data platform? So that's, is that about what you've kind of seen in the industry? And is this, just from your experience, like, because people are not aware that we have this data management platform and that we can do what others are doing?
Yeah, and then that's kind of the trend that we see as well, right? And Microsoft seem to be having the majority there. So yeah, and we will talk about some of the differentiators here in this session as well. Did we have Oracle in there in that list at all? No. Yeah. So it's probably around 50-60, I think, based on what we see. Okay, so that's Microsoft 42%. Okay.
Yes.
So
yeah.
hopefully this is kind of similar to what we see.
Yeah, and once again, this session is being recorded and you'll receive a link to the recording.
Yep.
Go ahead, Rama.
Okay, so let's talk about the challenges of some of the traditional databases over time. So over time, the traditional databases, transactional databases, become siloed, and the data start appearing differently. So same exact data will have different values in each of those databases because there's no single source of truth. An example of that would be if you have, for example, in a banking system, if you have a checking account in a bank and you also have your mortgage account in the bank that you've taken mortgage on, those two could be using completely different databases. So a transaction that's posted in one database may not have reflected on the other one. So that's a good example of how the data, same exact data, might appear differently in each of those databases. So data becomes out of sync. How do we solve this data inconsistency? That's why people created data warehouses. It's a centralized data warehouse. So you extract all the data, do some validation of the data, and then put it into the centralized data warehouse so that business intelligence queries could be run. Typically, if you see this data warehouse uses columnar format. So columnar format, we talked about row format for transactions. Columnar format is the most optimum format to retrieve the data, large amount of data, but you're only retrieving few columns. So as centralized data warehouses become larger and larger, which is multiple terabytes and petabytes of data, columnar format is more optimum to retrieve the data quickly and make aggregations and do aggregations on top of it. So that's the second, that's the columnar format method. Now, what are the challenges of this traditional data warehouses? Traditional data warehouses, the data that's going into there were always structured data, and data warehouses are not designed to handle unstructured data. It's very expensive. You can do some semi-structured data, but data it's an expensive hardware, expensive storage to store lots of data, petabytes of data into data warehouse, and the performance is not optimum to handle unstructured data. So now came big data. So big data refers to the ecosystem of tools for storing and processing large volumes of variety of data. It was described by 4 V's: volume, variety, velocity, and veracity. So typically petabytes of data. Challenges of this big data system was that because of large volumes of data, there's lots of tools that came into play, and so it became very complex to manage and maintain and configure these tools, and it was very time-consuming. Lack of skill set, scalability, and securing all this data became a nightmare. So then God created cloud. Right, in the cloud, there is lots of storage and lots of compute, lots of resources available. And so it's basically object storage. So you can get all types of data, structured, semi-structured, unstructured data real quickly into object storage, which is cloud storage, which we call Data Lake. And then now you can run different engines against the data lake. Okay, so now we have 2 architectures, right? 2 architecture patterns. One is data warehouse architecture, where you can get structured data, put it into data warehouse, and run your business intelligence queries against it. And then the second one is data lake architecture pattern, where you get all types of data, including all unstructured data, into data lake and run big data processing such as Spark, and run your data science machine learning models for your AI, for predictive modeling. 2 architectures. Now, there is complexity because there are 2 architectures that is needed. That's where, to solve that problem, Lakehouses were born. Lakehouse is an architecture pattern that combines data warehouse and data lakes into a single unified platform so that you can process all types of data, and also both business intelligence tools and the artificial intelligence tools can be run against the same data. So that's like Lakehouse pattern. So now let's review all these patterns that we have. Architecture patterns for lakehouses, where first data warehouse. So we talked about a vendor that starts with the basic capabilities of data warehouse. they would only provide support for structured data. Then they start with semi-structured data such as JSON, Avro, Parquet, and then they would start building perhaps graph and spatial on top of it, so that you can essentially run all BI, business intelligence queries, and some AI. It's still not a perfect world. You can actually have all types of unstructured data into data warehouse. It just doesn't make sense. So that's still it's still a pattern, architecture pattern. Pattern number 2 would be data lakes can handle all types of data, bring in all types of data into data lake. But is it really an optimum way to run your BI queries? It's best for AI, but is it really an optimum way to run your business intelligence queries? Because you need lots of work. On top of that, you need to create a schema. You need to have structured data on top of it to run analytics queries. The third pattern is, so that's why you can just bring in your structured data into data warehouse, bring in semi-structured and unstructured data into data lakes. Perhaps you can do some semi-structured data types in data warehouse, but your data warehouse query engine can reach out to data lake as and when it needs to run its queries. So this way, you're keeping them separate at the same time under the same platform. And so BI can be run, AI can be run as is optimum for each. Okay, so 3 patterns that are evolving. So what if there is another way? Okay, what's that other way? That would be the unified data platform for all your data. Right? Before I review this is an important slide that we want to spend some time on. Okay, yeah, there's a poll there.
And while everybody's kind of going through the poll, Rama, when I kind of take a look at this particular slide and this view, as we kind of talked about when we were getting this session prepared, and something that was, do you have to deploy a lot of different services to be able to do this? I see DevOps services, I see container services. Do I have to deploy all of those for the Oracle Data Platform, or how am I actually doing this?
Yeah, so it's yes and no question. So we are going to see some of the capabilities that comes into the platform of choice, and this is the big differentiator, Larry, that I'm going to be talking about in this session, is that other vendors have provided one or another, where Oracle is providing all capabilities and all platforms. So you choose data warehouse, you could run space analytics and spatial analytics and graph analytics, all those inside. We provide the rich platform, analytics platform inside the database. And if you want to run it in data lake, we provide lots of other services around data lake to be able to run all these different analytics against your data. So that's a big differentiator for Oracle, is that we are providing a choice. Yes, we are providing you multiple services, but you can also start with one platform to expand on most of 90% of your need into one platform. So that's a big differentiator. It's a good question. All right, looks like we ended the poll.
Yep.
Yes, we did. Yeah. So it's analytics is the winner there with 48%.
Okay. All right, great. It's good to know. So did that answer your question for now, Larry?
Yeah, it definitely did. It's something that when you look at all these, it's making sure that we're on the right path and what we're building out, and making sure we're using the right services, and just kind of how you see this, like the flow of like what services are connecting to my data. At the end of the day, data is gravity, it's volumes, it's everything around this, and so the other services are just kind of supplemental to it, and how you interact with that data set. So I appreciate you going through that, so thank you.
Yeah, absolutely. And so so you hit the nail on the head by asking that question. So Oracle Data Platform, let's just review this Oracle Data Platform on the whole. And it might look like it's similar to all other platforms that we provide. That's why we are going to walk through, I'm going to walk through the differentiators before I give this over to Marty to do his demo. So we provide transaction processing, yes. And we provide data lake, we provide data warehousing, we provide managed open source big data services, and we provide your data science tool, all under the uniform governance and security. And you get the similar performance across your data. That's the middle part. On the left-hand side here, you have, Oracle applications that are, so you may be running eBusiness Suite, PeopleSoft, Hyperion, Siebel, and we provide you all type of connectors and integration services to reach out to those applications and get the data into Oracle Data Platform. We provide you KPIs and metrics and pre-built analytics tools to make the life easier for customers so that they can run their rich analytics against the data. And on the right-hand side, we provide Oracle Analytics Cloud, which is a comprehensive analytics cloud service that is highly integrated with our Oracle Data Platform, with integration services and with applications. So that's number one. Number two is, if you have already converted those applications, eBusiness Suite, PeopleSoft, all those applications into respective SaaS services, for example, ERP, HCM, CRM, those type of SaaS, we provide all type of connectors and integration services to connect to those SaaS services to get the data into Oracle Data Platform and be able to run analytics against it. Now, if your choice is like, okay, I already have Power BI, Looker, Tableau, or even other tools, you can bring in those. We support all those third-party tools into our platform, and you can easily start leveraging the power of Oracle Data Platform using those tools. And we also provide other Kafka support, Informatica, all other, there is no space here to put all this ecosystem of tools that we support in this slide, but you get an idea. And then application development side, we provide DevOps services, containers, Kubernetes, API management, and low-code Application Express, which is extremely comprehensive and very popular tool, web application tool that's free, that comes with Oracle Data Platform. So this is overall a view of Oracle Data Platform. Now let's talk about the differentiators here. So number one differentiator is that Oracle, so we talked about the vendors that starts with small basic features, whether it's data warehouse or data lake, or public cloud vendors that bring in other open source tools to build data warehouse and data lake together under the platform. So that's based on infrastructure. So data warehouse based product, data lake based product, and then we have infrastructure based product, right? All the three. So what is Oracle's differentiator here? Oracle's differentiator is that we are not building basic capabilities. We're not starting with basic capabilities, adding capabilities on top as and when we need it, right? Oracle databases have been leading the industry for the last 40 years. Top banks, top retail, top healthcare companies, they all are powered by Oracle databases. They all run mission critical workloads against Oracle databases. So the reason that they all run their mission critical workloads in Oracle, behind Oracle, is that it has rich capabilities. Oracle databases are built with rich capabilities, whether it's performance or capabilities for analytics, OLAP, OLTP, any type of workload can be run, and it has those capabilities. So when you bring in a product that already had rich capabilities built into it to Oracle Cloud, and using those innovation into Oracle Cloud, you get a platform that already have everything that you need to build your analytics tools, whether it's BI or AI. So that's number one differentiator. We are not starting with basic and then keep adding capabilities on top. Second differentiator here is that if you look at other vendors, they are leveraging a third-party public cloud, right? That's where they developed their product in the last 10 years. Because it's easy to develop product on another infrastructure than when you are standing up an infrastructure, right? So having said that, when they use other third-party infrastructure, that infrastructure is general purpose, based on general purpose hardware. They're not purpose-built hardware. Oracle has provided a database platform, database hardware that's optimized to run Oracle database. So it's purpose-built hardware. Hardware works with software. There's intelligence built into hardware. There's intelligence built into software. They both work together to provide the maximum ROI for customers. So when these vendors provide basic capabilities in their product because it's faster and they make it easy to provide those basic capabilities, it looks like it's easy, but they're counting on public cloud resources, right? Because in the public cloud, you have near infinite amount of compute and storage and cache, memory, all that is available. So they're counting on those scalability features to give more power. So basically, lack of features, they're compensating the amount of hardware resources to fill the gap of lack of features. So they have time to build those specific features. That's how it's designed. That's how it's easier to produce a product. Oracle has had these features for 40 years. So the problem with that approach is that, let's take an example of a query engine that cannot identify a join ordering of a query. A query is executed and the query engine, if it cannot identify join ordering, to execute that query with less resources, with less hardware, then it's going to spin up more hardware. That's how these products are designed. Whereas Oracle's optimizer is very powerful. Oracle cannot even give that kind of a design because that's not the design that was used in the on-premise world, right? Customers cannot just spin up hardware. They wanted a product that can run efficiently inside a specific amount of hardware that they already purchased. And that's an expensive criteria to have to do that, right? So Oracle produced that product, and that's where Oracle was leading. So now when you bring that product into powerful engine into Oracle Cloud Platform, it reduces cost. So the first differentiator was it produces most ROI for customers. Second is it reduces cost for customers. Thirdly, because we thought Oracle was designed this way, it's also a hybrid model, right? So what do I mean by that hybrid model? Why do customers care about that? When, for example, Oracle Analytics Cloud is a cloud service that runs on Oracle Cloud. We also have Oracle Analytics Server with same exact capabilities that customers can run today on the on-premise and also inside compute within Oracle Cloud. Same thing, Oracle Database that runs today, they could bring into Oracle Compute, compute in Oracle Cloud and run it there. It's the same exact database engine that they can run. So it's a hybrid model that we are providing, and we provide rich capabilities for and under autonomous databases that Marty is going to be doing a demo on. So it's a hybrid, and it's also multi-cloud, hybrid and multi-cloud. And the fourth differentiator is the differentiator that we talked about. We provide rich capabilities for connectors and integration services to reach out to SaaS applications and also other services, right? So the differentiator here is that Oracle is the platform that gives you IaaS, PaaS, and SaaS, all the three layers inside this inside the cloud data platform. So those are the four major differentiators that we have. When you're making a decision as to which platform to choose, these are the choices that you need to make. And on top of that, if you are running, if you have a platform, if you're running your databases, you're probably not using Oracle, or you're using Oracle databases and MySQL. So we provide you a rich MySQL analytics platform. It's called MySQL HeatWave in Oracle Cloud. The two most popular databases are running in Oracle Data Platform under Oracle Cloud. I'll stop there and then see if there are any questions. Any question on this differentiator? Is it resonating with anybody?
I don't see any questions in the Q&A at this point. Looks like we're got them all squared away.
All right. That's great. So to answer Larry's question of, do I have to have all those services? You can, if you want to start with just the data lake, bring in all the data. And then if you want data warehouse, you would spin up data warehouse. If you want machine learning, you would spin up that service. You would need, if you want to run BI, you would spin up that. So you can do this model of building in. It's like a modular approach. Or you can, if you have your 90% of your data sitting in data warehouse, bring all the data into Oracle autonomous databases. And what we are providing Oracle database is amazing. We provide all type of analytics, right? So big differentiator here is it's not just supporting you with structured data, semi-structured data such as JSON, Avro, Parquet, ORC, XML, or unstructured data inside autonomous databases. So we do that. We provide you native support for everything. We also provide you graph analytics, spatial analytics libraries, IoT data features, machine learning models built into this Oracle database platform so that you don't have to keep writing a ton of code, right? This provides the maximum ROI for customers when you are able to leverage all types of analytics inside the database. And for application development, we provide you API support, we provide you Mango API, we also provide you, as I said, application experts to write your applications. So inside Oracle Autonomous Database, just like these other vendors are providing, starting with the data warehouse platform, basic capabilities, we are providing you rich transaction support, where Oracle's mission critical OLTP applications we're running again behind Oracle for many companies. We are providing that transaction support. We are providing your data warehouse support, and we are providing your data lake support inside autonomous data warehouse databases. Okay. So the other one is MySQL HeatWave, same exact feature. So Oracle have innovated a lot in Oracle Autonomous Databases or Oracle databases in general. We are bringing in some of the capabilities such as analytics platform into MySQL HeatWave. We are bringing in machine learning model support into MySQL HeatWave so that you can run transactions, you can run your data warehouse, you can run your data lake inside MySQL HeatWave. Okay. And then the third approach is if you're running your comprehensive big data platform based on Hadoop today, you can bring that into Oracle managed open source model and run your big data processing using data lake. You can have managed open source based managed Spark based open source tool called Dataflow. It's managed for you. And then we have comprehensive data science and machine learning built into this platform. So net, key thing to remember is that we are providing you a comprehensive platform from wherever you want to start. Right? You don't have to start the whole thing, boil the ocean. You can start one at a time, and we provide you everything, most of what you need for your analytics platform. Okay, real quickly, let's just recap everything here. Oracle is providing you a managed and converged data platform. So you can combine your transaction databases, data warehouse, data lake into a single platform with complete support for all types of data. And then Oracle is the only platform that provides you SaaS integrations, all the way SaaS, IaaS, PaaS together in a hybrid model. And industry-leading tools like Golden Gate is extremely powerful. So I had a customer who asked me, I want to have my purchase order that's posted in my new business suite to appear immediately real time into my data warehouse. I'm not able to do that in any other platform. Can Oracle do that? Using Golden Gate with complete transaction consistency, you can transfer that transaction, that the purchase order posted in e-business suite, appear in data warehouse with very minimum latency. Full portability without vendor locking. So it's an integrated suite of applications. We talked about application analytics as well, where you have a built-in KPIs and metrics that Oracle already provides you to integrate to build the end-to-end analytics platform. All right, if there are no questions, I would like to transfer this over to Marty. We are going to start with autonomous database demo, and then the next session would be MySQL, and then followed up with big data services. Okay, take it over, Marty.
All right. Thank you so much. Rama, hi, everybody. My name is Marty Kupar, and I'm from the product management team for Autonomous Database. And apologies ahead of time if you hear my teeth chattering. I'm in Boston, and it's freezing. So I'm kind of dying here. Anyway, so what we're going to do today, and we're going to have a lot of fun, is we're going to go through a demonstration of really how to put your data to work and get the most of your data out of your data to improve business outcomes. So we're going to be using Autonomous Database and its Lakehouse analytics to kind of learn more about customers and how to make targeted offers to them to basically keep happy customers, improve the bottom line, et cetera. So we're going to do this all from within the context of a company called Oracle Movie Stream. So Oracle Movie Stream, it's just a fictitious online movie streaming company. And they've been phenomenally successful, right? So they're getting lots of customers, they're gathering all sorts of structured and unstructured data, click streams, who's watching what, et cetera, what they are watching, what they're not watching, because they can see, what are people clicking on, but not necessarily watching and whatnot. So they're able to understand the journey that their customers are taking. So they have all of this raw data, and what we're going to do is we're going to see how using Oracle Cloud and using Autonomous Database, they'll be able to get better insights into their customers, enhance their user experience, and again, as I mentioned, ultimately improve profitability. So there's a lot of steps that we're going to go through in the next 15 minutes. So the first thing we're going to do is actually look at the service itself and the application. And what you'll realize, I hope, there's actually a lot of intelligence that goes into the deployment of this movie streaming service. So we're going to look at what that intelligence is and, frankly, how it was developed. Okay, so we're going to be to derive the intelligence that drives the user experience. We're going to be loading and linking to data sets that are in a data lake, right? So data that's in an object store. So now that we have access to all these different types of data sets, we're going to, and what's nice is that some of the data sets are actually going to be living in the database. Some are going to be living in object store on Oracle Cloud. We also are going to be pulling in data from S3, right? So different data sets from different places, and then just allow SQL access to all of that data, regardless of where it resides, right? So that will allow, we're going to be using Analytics Cloud, but because it's Oracle SQL, SQL is the language of data. The world supports Oracle SQL, right? So you can use Analytics Cloud, but any other application to analyze that data. So we're going to be creating some self-service dashboards, discovering some potential challenges, and then we're going to say, well, we're noticing that we happen to be losing some customers. Well, let's try to get in front of that, right, and predict churn, and produce some localized offers using machine learning and spatial analytics. And then we're going to recommend movies, like what should people be watching, and we'll be using graph analytics to do that. So those are the 5 steps that we're going to be going through in the next 10 minutes or so. And what I would say is that there's live labs for everything that I'm doing today, right? So everything that we're going to be going through, you could do yourself, and we'll show you where to go at the end of the session so you can learn. So let's log into Movie Stream. This is our application. All right, and when I log in as Blanca, one of the first things that Blanca has is this alert in the top left. She has this notification for a pizza offer that she could redeem at Mama Lucina, which happens to be a local pizza place. She sees what's popular on Movie Stream. This is kind of standard, popular in her area. So, what are her neighbors watching? And then movies that are targeted to her based on her viewing pattern, broken out by different genres, right? So she has this very tailored experience. And of course, everybody has a tailored experience, right? So when I go in here as Emilio he's seeing movies that are recommended to him based on his experience and his neighbors and community, if you will. So the ADB, Autonomous Database Lakehouse Analytics, really play a critical role in how this was built. And frankly, I should have said too, it's not just the analytics, it's also the application itself is transactional, right? And it's driven by Autonomous Database. And everything that that interactive experience, this was a Node.js application, right? Built with Vue.js, and it's using REST endpoints against Autonomous Database, right? So Autonomous Database could present itself through SQL. You make SQL queries. You can have REST APIs. There's a MongoDB API against ADB. So there's lots of different ways for building applications on top of Autonomous Database. In addition to, I think people think of SQL all the time. So let's look at how the Lakehouse produced or helped produce this application. If you think about the different sections of the page, right? The first was up here on the top, right? Where so you have your specialized pizza offer. Well, that's the result of machine learning, right? So she was predicted to be at risk of leaving. So based on where she lives, she got a specialized offer, right? So combined spatial analytics and machine learning. The movies that are displayed, what's popular is basic analytics suite SQL over transactions. What's popular near her, combine analytics SQL and spatial analytics. Award winners is actually coming from a JSON feed, right? So those are Academy Award winners. So we kind of decode JSON to be able to produce that result. And then graph analytics are being used to provide, Bianca loved dramas and comedies, et cetera, and these are the movies, and that's using sophisticated graph algorithms. So let's step through each of these individual areas. And what I should say too, of course, is we're using one engine for across this entire application. And what does that mean, right? So 1, faster development. 2, simpler deployments, right? You don't need different analytic engines for each of your different types of, for spatial, for graph analytics, for your SQL. And it's one engine that's doing it all. And it enables you to develop these applications faster and deliver smarter solutions more quickly. So to start, what we did is we started with deploying an autonomous database and then loaded data from the data lake. An autonomous database provides graphical tools. It's really just zero code development of building tables and loading data from an object store. So an object store, if you think about it, it's just a pile of files. In this case, it's stored in what we call folders. It's really like logical objects. So we have a gold zone in our object store where we're loading customer contact data, right? So that's a folder with a bunch of files in it. And if what that one drag and drop operation is going to do is it's going to create a table. The files is inspected, and these are the columns that were derived from it. So we're going to create a table and populate it from this file. So this happens to be a CSV file, but there's also data in different formats. In this case, we have partitioned Parquet files. There's also movies are in JSON format. I think genre is a CSV file, but we're just going to create tables over these sources. And you don't have to worry about the type of data. We'll just figure it out. ADB just figures it out, right? So now these 4 tables have been defined. I can go look at genre, the table's created, and here's the contents of the table, right? Action, comedies, etc. We also we're going to be doing a pizza promotion, and in S3, on Amazon S3, we have some third-party data, right? So we have the locations of our pizza restaurants that are being provided by a third party. And we're going to use that for our promotional campaign. So let's see how we securely integrate data from S3 into ADB. So here's our bucket. It's not public, right? And this is where our partner has its data. And I'm drilling into that bucket, and I can see my CSV file with all the pizza locations, and I'm going to need that for my promotion. So the first thing we do in Autonomous Database is I'm actually in what's called Database Actions, a SQL worksheet, is I'm creating a credential that allows me to securely access that file, right? Or securely connect to S3, right? To AWS. Now that I have that credential, and that credential is given rights to access that bucket, I can even through SQL see, hey, what are the files that are in that bucket? Well, I have the pizza location CSV file, right? So we can kind of flip over and see that's that same file that we're looking at here, but we can query S3 through SQL to see what files are available. Now I'm just going to go back to the same tool I was using before, create a pointer to that S3 bucket, and call it the marketing S3 pointer. It's pointing to that bucket. Now I'm just going to load that data in exactly the same way I loaded data that was from on OCI. Drag pizza locations over. And I run. And now I have my pizza locations. Awesome. So I've loaded customer contact information, customer sales information. I have pizza location data. Well, now I have some data that's still kind of in flux, right? It's on OCI. It's some customer segmentation data. And instead of actually loading that data, I'm going to link to that data. Right, so I have a customer extension, which has demographic data. That's in an object store. I have customer segments also in the object store. And again, this UI looks the same, but instead of actually doing the load, I'm going to take customer extension, that demographic data, and I'm just going to point to it. And that's going to be a table that's pointing to data on your data lake. And when you query it, it's going to go to the data lake to fetch that data. So when my data scientists start updating the customer segmentation, the customer extension, we're not going to have to make any changes into the warehouse, right? We'll be able to just use that external data and query an external table. And when the external data is updated, our table's automatically updated without anything required. So this step is actually just simply creating an external table without doing a data load. And now we're looking at the data with all these different customer attributes that are on the object store. So we're really enriching it. We're enriching our data with customer segmentation data, pizza location data, customer contact data. Let's start running some queries across all that data, right? And so we have a SQL worksheet. We were in it just a second ago, and it's showing all of the tables that are now in our schema. And, you now have the power of Oracle SQL, right? To say, hey, I want to look at my genres. Let me see my sales across my different movie genres, right? And here's that result. So I could take that result, save it to a spreadsheet, export it, whatever I want to do. I can also create a view. You could think about a view as being a saved query, right? And that is something I'm going to be exposing to my users. Right. And what it's doing, this view, is it's doing some minor wrangling, right? So breaking your ages up into different segments. It's also joining data from the object store, customer extension, with data that's in my database, data that's in different places, right? And it doesn't matter where the data is coming from. We're just running queries. We're creating this view that will allow us to run queries across the data lake as well as the database. So what I'm going to do now is say, well, I'm going to run a query across all of this, and I'm going to do what's called an RFM analysis, recency, frequency, and monetary analysis. What customers are big spenders? Monetary. Are frequent visitors? F, that's the F part of the recency, frequency, and monetary. And R is when's the last time they came, right? Recency. So we're going to break our customers into quintiles and look for those customers who have been big spenders in the past, but they haven't been around in a while. So here's a list of the customers who have been big spenders in the past, and hopefully we haven't lost them, right? So we're actually looking in the past at people we may have already lost, but we probably want to get in front of that at some point and maybe do some predictions as to who might leave in the future. The beauty of this is now I use any tool I want, right? I was just using SQL, but the SQL, it's Oracle SQL, so I can use Analytics Cloud here. Use that sales dashboard. Some of this data is coming from the object store. Some of this data is coming from the database. And I'm now going to look at, here's a thumbnail of, this is Analytics Cloud, a thumbnail of my data set or a thumbnail of the different attributes that are in my data set. Either income level, age range, et cetera, right? So I have my new data set.
And Marty, this is definitely a fantastic demo to keep going through, but we did just hit the time.
Yes. So yeah, that's too bad. So I tell you what, guys, what we will have done at the end, right, is we're going to go through this. We're going to create some dashboards really easily. We'll use autonomous database to predict churn, who's going to leave, potentially leave. We end up creating a model that's pretty accurate, right? 92% accurate. We then use graph. So now we saw customers who might be leaving or might have left. Now we're going to predict who may leave in the future. And then we're going to use graph analytics, right, to recommend movies to them. And then finally, when you save that result of the recommendations, it's like here's like movies that are recommended using graph analytics, which is interesting, right? It's saying these are customers who are similar to me, what they watch. Well, let's recommend it to them. That's then fed right back into the application, right? And so now the application is showing a whole new set. So we've operationalized our insights, right? Which is very cool. There's live labs for all of this. And what I want you to do is, if you want to try this yourself, go to bit.ly/get started with ADB. You'll have everything there. Sorry to interrupt you, Larry. I just wanted to get at least to that part.
Yeah, I appreciate it. Well, and it looks, this is something that I think the demo is something that we could potentially share out in the material so that people that join can watch through this. But I mean, it's a great demo. There's a lot of information here, and it's definitely something, I appreciate you coming in and Rama coming in to talk about this, because this is something that this is a huge topic. This is a topic that I want more people to be aware of. And we definitely need to bring in more in this series and do more of this. So this is definitely something that this is not the only one we're going to do of this. We're definitely going to bring these two individuals back so that we can learn more from them on this journey for, Oracle Autonomous Database, data warehouse, all of these different mechanisms that can be used on Oracle's platform. So I really appreciate the time from you and Rama on this journey. So thank you everybody that joined today. And we'll definitely be sharing out this recording. We'll definitely be sharing out material. A replay of the webcast will be available on the OU web in 2 to 3 business days. So that link where you registered for this, you'll be able to go back and watch this. And I know we do have a couple items in the Q&A, so it's something that we'll get some answers back to those. I do appreciate people asking, like, hey, you need more marketing, you need more individuals talking about that. This is the whole goal here, is we're gonna start talking about this more on this journey. So please keep an eye on the Day One and Beyond page, because we are going to be adding more to this series, adding more to this topic. And again, Marty and Rama, thank you both for joining us today. I'm looking forward to having you back, because I definitely learned a lot today about data. It's really, a data lake, I thought it was just fishing. Now I know that there's more to it than just fishing. So Appreciate you all. And thank you everybody for joining, and have a great rest of your morning, afternoon, or evening.
Thanks, everybody.
Thank you.
Thanks, everyone.